Good afternoon, sir. Myself, Yad Narayana from Department of CSCA section. Today I am here to explain about my topic for CA2 assignment, and the topic is to differentiate thermo and thermosetting plastics. Moving to next slide. In this topic, we are going to discuss about introduction to plastics, what are thermoplastics, characteristics of thermoplastics, what are thermosetting plastics, characteristics of thermosetting plastics, processing techniques for thermoplastics and thermosetting plastics, applications of thermoplastics and thermosetting plastics, and conclusion. Moving to next slide. Introduction to plastics. Plastics are synthetic materials made from polymers that have become essential in various industries. They are broadly classified into two main categories: thermoplastics and thermosetting plastics. Understanding the difference between these two types is crucial for applications in manufacturing and design. Moving to next slide. What are thermoplastics? Thermoplastics are a type of plastic that becomes moldable upon heating and solidifies upon cooling. This process can be repeated multiple times without significantly altering the material's properties. The common examples include polyethylene, polypropylene, and polyvinyl chloride. Moving to next slide. Characteristics of thermoplastics. Thermoplastic exhibit high flexibility and can be easily reshaped and reused. They typically have lower melting points compared to thermosetting plastics. Their molecular structure allows for easy processing through methods like injection, molding, and extrusion. Moving to next slide. What are thermosetting plastics? Thermosetting plastics are polymers that undergo chemical change when heated, forming a rigid structure. Once set, they cannot be remolded or reheated without degradation, making them permanent. Examples include bakelite, urea formaldehyde, and melamine resins. Moving to next slide. Characteristics of thermosetting plastics. Thermosetting plastics are known for their excellent heat resistance and structural integrity. They are typically more durable and stable under high temperatures than thermoplastics. Their cross-linked molecular structure provides superior mechanical properties and chemical resistance. Moving to next slide. Processing techniques for thermoplastics. Thermoplastics can be processed using various techniques such as extrusion, injection molding, and blow molding. Their ability to be remelted allows for creative designs and modifications during production. The processing methods chosen can greatly affect the final properties and applications of the product. Moving to next slide. Processing techniques for thermosetting plastics. Thermosetting plastics are processed through methods such as compression molding and resin transfer molding. These methods require heat and pressure to initiate the curing process, leading to a permanent shape. Once cured, further processing is limited, which impacts design flexibility. Moving to next slide. Applications of thermoplastics. Thermoplastics are widely used in consumer products, packaging, automotive components, and medical devices. Their ability to be recycled makes them a popular choice for sustainable product design. Innovations in thermoplastic materials continue to expand their application across various industries. Moving to next slide. Applications of thermosetting plastics. Thermosetting plastics are commonly found in electrical insulators, telephones, and automotive parts. They are favored in applications requiring high heat resistance and strength. Their stability and durability makes them ideal for use in harsh environments. Moving to next slide. Conclusion. The key differences. The key difference lies in their processing. Thermoplastics can be remolded while thermosetting plastics cannot. Thermosetting plastics are offer superior durability and heat resistance. Thermoplastics are generally more versatile. Understanding these differences helps in selecting the appropriate type of plastics for specific applications. Thermoplastics soften on heating. Thermosetting plastics do not soften on heating. Thermoplastics contains long chain linear structure, while thermosetting plastics contain 3D structure. Thermoplastics can be reshaped and reused. Thermosetting plastics cannot be reshaped. Thermoplastics are soft, weak, and less brittle, while thermosetting plastics hard and strong. Thank you for giving me this opportunity.